Hi, my name is JR Hurd. I'm here to tell you about a great Python library called Hypothesis. I'm going to walk you through sort of how I came to learn about it and sort of how you can think about it and use it yourself. I think it's really great, and I hope by the end of this talk you also think that. Before we get started, I would love to see a show of hands. Who has heard of the terms generative testing or property-based testing? Anyone? Cool. So that's like a third of the room. Good to know. Great. So I'm going to tell you a little bit about myself. My name's JR. I look like that. I used to work for Yelp for like 6 years. If you use the website, you used a lot of my code. I really liked it. It was a great place to work. I quit a couple of years ago. I've been doing sort of my own thing since then. Lately, I've been doing a little bit of work for a tiny startup in Beaverton, like 3 people, called eWind Solutions, which is making a wind energy kite drone. So that's been pretty cool. I really like functional programming. Clojure/ClojureScript are my favorite languages. I really like making little toy games in ClojureScript. I like seeing the weird horror movies they show at the Hollywood in fall. That's like one of my favorite things of the year. And I really like video games. I know I've been playing a lot of Slay the Spire lately. I also have a blog at jrherd.com. I think it's really good. I think you should go there. Like 5 people have seen this stuff there. So after this talk, go look at it, read my stuff, and tell your friends. I'm really proud of the stuff I put there. And this is a tasteful collage I made of my cat Frank while I was waiting for the pizza to arrive. So now you know everything there is to know about me. Oh, except that there is more stuff to know about me, which is that I've been spending this year volunteering at a local high school, like Jay just mentioned. I'm at Madison High School 2-3 times per week. I found out about this through an organization called TEALS, and you can do this too if this interests you. This is like, we're getting toward that. There doesn't seem to be a posted deadline for when you have to apply for next year, but like the sooner the better if you're interested in this. But it's been great. The idea is that tech folks from industry come help teach computer science in high school classes before work. And so I'm helping out with a few classes. There's a robotics class where I'm useless because I don't know anything about robots, except I'm learning a little bit at the kite place. There's a senior design class, which, come back next month to find out more about that. I'm looking forward to seeing their presentation. And then there's this Python class that I've been spending most of my time and energy and brain power on this year. And that's sort of the context in which I found myself using Hypothesis. A couple months ago, I gave a lightning talk here about a project that we had done in that Python class. It was a pretty popular lightning talk, so I'm going to recap it for like 1 minute as I fiddle with this microphone. At the start of the year, Tamara O'Malley, who is the teacher I work with for this class, she's the classroom teacher. She does a lot of the work. Actually, I don't know, man. I'm going to be doing a lot of typing, so we'll see. Maybe we can just have it on deck in case. Cool. Sorry about this, guys. My ear is like really weirdly shaped. So anyway, the classroom teacher had a watercoloring robot that she bought from watercolorbot.com. You can get them for $300. They're a great classroom tool. Maybe you don't need one for your house, but it's great in this context. And it turns out there's all sorts of great ways to control the bot, but it wasn't obvious how to fit it into a Python class. So I sat down and I wrote a little library that lets students write programs that control it. And this is what it looks like in action. This is it painting a student's solar system program that she had written, which in a really sort of minimalist style that I liked a lot. And here are a couple more. One thing I really want to point out for all these really is that the students who made these programs, like, this was the start of the year. We had just covered, this is what a Python line looks like, and this is what for loops look like. But we hadn't covered, functions, just really anything. We hadn't covered if statements. I mean, this is just bare Python. This N64 logo is like 750 lines of hideous, beautiful code. And then this last one I was really impressed with. This is a student's original work as well. So anyway, that's something that we did in this Python class at the beginning of the year, but most of our projects look more like this. And so this is where we enter the realm of the demo. So we're going to see how this goes. One thing I do want to point out is the reason I'm doing my talk in this format is one of my favorite things about the Clojure community is that we have this tradition of having our talks be basically entirely live demos, despite the sort of danger of that habit. And it usually works in Clojure, and I think it's going to work here in Python land. That's just something that I like a lot from the other meetup I go to that I'd like to bring here, and I hope you enjoy. So I'm going to show you another project that we worked on immediately after the watercolor bot. And that was a simple program that checks the strength of passwords. And, since I'm if we have tech people here, you're going to realize that the constraints that this little program imposes are like arbitrary and horrible. But I told the students that I showed them the correct horse battery staple XKCD. Like, don't worry, they know how to make good passwords. So this is what the program looks like. It prompts you for your username and your student ID, and I will explain that in a moment, and asks you for a password, and it prints out bad if it's bad, and prints out good if it's good. Okay, so anyway, you get the idea. I'm gonna do it one more time, but you get the idea here. It takes a password. It says whether or not it is quote unquote good. So here is the well, a little bit of line wrapping. We'll live with it. Here's a sort of verbose explanation of what it means for a password to be good. I know, again, this is arbitrary and bad, but it made for an okay project. And I'm going to walk through these really quick because these are going to be pretty important for the rest of the talk. So the rules we imposed are the same one that the public school system here imposes, which is that passwords have to have a length of at least 8 characters. They can't contain the student's username or student ID. And they have to have at least 3 categories of character in them. And a category is, lowercase letters, uppercase, digits, and symbols. So there's 4 possible categories. By the way, I wanted to mention earlier, but this is still an okay time, that I want this talk to be accessible to all skill levels per, the sort of great mission of this meetup group. And so if anyone has a question, whether it, sounds like a simple one or an advanced one, raise your hand. I'd love to answer it. So anyway, this is the talk. Excuse me. This is the program, and that's sort of the setup. And so once we distributed this assignment to the kids, I just immediately realized, oh crap, we're going to get like 25 of these programs, rolling in the near future. And the idea of grading them by hand sounded just like completely hideous to me. In particular, we've got all the constraints, and God, there's all these edge cases about like, does it handle the empty string? Does it handle, I don't know, a bunch of uppercase A's? What does it do there? Having to test all that by hand over and over for each student was just like, sort of an untenable idea, particularly when paired with the fact that, each student is allowed to submit multiple versions of the program as we give them feedback and they fix bugs, et cetera. And so doing that 25 times, N times, just wasn't an option, particularly considering they don't pay me. So, this is a pretty common thing in programming. We have programs, we want to make sure that they work. What we usually do in this situation is write tests for them. And so we're going to be talking, as you may have guessed from the talk's title, about tests a lot for the rest of this talk. Again, show of hands, who has written, tests for software before? Cool, so that's the majority of the room, but I think there's still a couple of people who haven't. And so for the sake of those folks, I'll just briefly explain that when you're programming, the main thing you do is you spend your time on your main program, the one that, makes your company money, or the little game you're working on for fun. Just there's the main thing you work on over here, this hand. And then this hand over here is a separate sort of program that you write alongside the main program. So these are your tests. As you add more features to this thing, you add more code over here, and the code over here in your tests just sort of pokes and prods at the main program and makes sure that it works for some definition of works and for some level of confidence about the amount that it works. So that's what tests are, and I'm going to show you some, make it a little bit more concrete. And there's going to be a little bit more context. First, I'm about to use an editor called PyCharm, and for beginners in the audience, there's going to be some like whiz-bang sort of windows popping in and out. Don't feel intimidated. I'm just using PyCharm lately because I'm trying to learn it, but I used a much simpler editor for years and years. You don't need to have this, fancy thing in order to program Python, but it is free, and I've been liking it, so check it out if you find it interesting. So I think I want to point out, let's bump this up. This is about as big as it's going to get. First, you don't have to read all this, but the main thing I'm trying to show you, if I hide this if statement, is that our program is mainly just a single Python function. It takes as input the username and student ID, the sort of Gerhard 12345 you saw me entering earlier. Then it takes the password, just the thing we're trying to verify the strength of, and then it returns true if the password is good, false if it's bad. And so I'm going to just take this off the screen so that you stop looking at it, because the goal of this talk is not for you to read this code. This is just how I happen to implement it. Instead, the goal of this talk is to test this code. So here I have a separate file where I am going to test the program. I feel like there was one other sort of groundwork thing I wanted to say. I think it was that I'm using a test runner called PyTest. but there's all sorts of different ways to write tests in Python. This is just one I like because I'm a functional guy and I don't really like classes. So the first thing we do is we have to import the module that we're trying to test things of. And I'm going to write just a little wrapper function here that I'm going to call the same name is password good with the right number of letters, the right sort of order. And it's just going to be a wrapper for this password checker dot is password good. I'm going to, always use jherd1345. There's an argument to be made that this is a bad testing strategy, and I think by the end of this talk you will learn how to improve it, but I'm not going to do it. You're going to have to figure out how to do it yourself. So now we've got a function that we want to test. We've got to write a test for it. So in PyTest, the way that you write a test is just by writing a function whose name starts with test underscore, and then you got to figure out what you want your test to actually do. So I think a good way to start testing this program is to make sure that short passwords are rejected, that they are, the function returns false when it is given a password that is fewer than 8 characters long. So let's say test, too short rejected, and we do. I wanted to start this sentence in a different way, but oh well. The way that you do stuff in tests is by writing assertions. So this is a built-in keyword in Python, assert. You just type assert, and then you type something that evaluates to true or false. So I want my test to assert that when you call is password good with short password and what's good short password, I want it to have the right number of categories. So it's got to have at least 3. So let's do like a Z lowercase and then like a $sign and then like a 6. And that's a test. So I want to also assert that it has particular value. And so there's several ways of writing this assertion. Some Python experts will probably not like the way that I write this, but I think there's a syntax that's the most legible for beginners would be this. I know there's also, you could do is or you could do not, whatever. I'm going to do this. By the way, how's the font size looking so far? Good? Cool. So let's run this test. Bam. So this is what it looks like when a test passes. You see a little dot, and at the end it says 1 passed, or to say a certain number passed. Let's take a look at what it looks like when a test fails, because we're going to be seeing a lot of that over the course of this talk, and so it's good to be familiar with that early on. So I just changed it so that it asserts that short passwords are marked as good, and lo and behold, the thing fails. And the way in which it fails is on this line. It says, is password good is equal to true. There's something wrong there. And then PyTest is telling us, well, then that ends up being false equals true. And the false is coming from this is password good when given this too short password. So fine, that's what a test failure looks like. Does everyone, make sense so far? Great. So I'm going to change this back. And at this point, I'm going to start copy pasting in a few other tests that I've written sort of beforehand. And I was going to do this, on different screens, so you didn't see this, but I don't have enough sort of ports on my computer. So as Jay said, you're going to get a slight peek behind the curtain. Hope you can deal with it. So here is a test with a couple of assertions that make sure that, passwords with student info in them are marked bad. And again, as you see at the top of the screen, my username is jherd, and my student ID is 12345. So Carl's Jr. Herd, even though it has my name in like a different sort of capitalization level, should still be marked false, indicate that it's a bad password because it has my username. And hi there 1345 should also be marked false for, again, the reason it has my student ID. And so I'm going to run that, and hopefully we will see 2 happy lots this time. Great, awesome, doing good so far. And I'm remembering one last thing I meant to do before this, which is to pick up master. That hasn't affected anything so far, but it was about to do something horrible. So glad I remembered. Now let's add one other test. This is a test that makes sure that we have rewind. Sort of the way that you write tests is to think, gee, what are ways in which my program could break? Or like, what are ways in which, I may not have implemented it correctly? We tend to call those edge cases. And, then you sit down, you try to think of edge cases off the top of your head, and then you try to write tests that sort of cover those, that make you confident that your program behaves well in the presence of those edge cases. And so because I was, this is the second Python program these kids had basically ever written, I had a sneaking suspicion that some of them may have, misimplemented the part that said at least 8 characters, and they may have said only, more than 8 characters. And so I figured it might be useful to write a test that tested to make sure that a valid password, which as you can see, this has 3 categories of character and is 8 characters long, it should be marked as true. And so let's run it and see what happens. And oh, dang, we've found a failure. Again, reading through this line is failing. It's failing because false is equal to true, and that's bad. And the false is coming from this is password good call. And so at this point, this is what testing is like. You have to, the test, it will, rather, tests can detect bugs, but then it is up to you as a human to interpret and fix the bug. So here I'm seeing as a human that, okay, test is called test exactly 8 characters, and I also explained it. So that gives us a little, sneaking suspicion of what the problem might be. And just by looking at it, I can convince myself that yes, this password has 3 categories, and that should be good, and it's long enough, so that should also be good. So let's take a quick look at the code, and lo and behold, this last conditional, oh geez, that's got a greater than 8, and it should be greater than or equal to. So whoops. But this is what it's like both to test. Again, the main impetus for me writing these tests was so I could then run them on these like 30 different student programs or 30 times n or whatever. But this is also what testing looks like when you yourself are working on writing tests for your own project or for a company. You sit them down, and sometimes you write a test that you're confident will pass, and it just stubbornly fails the first time you run it. You got to figure out, oh crap. But that's actually a really good thing because I'm sure this is obvious, but when a computer, like when a test catches a bug on your computer, that is a bug that was not caught by a human being who was using your software. And so like it's just great news when you write a test and catches a bug and then you fix the bug. That is, that just should feel really good. So again, let's run this one more time and we should see 3 happy dots. Great, awesome. So there's just a couple more tests we're going to run through, and then we are going to get to the interesting part, I promise. Here are some tests that make sure that if a password only has 2 categories of character, that it is marked as bad. And I'll show you those inputs in a second, but here we've got our 4 dots. And so those inputs, they only have 2 categories of character. It's not very interesting, but you can, look and convince yourselves that yes, that is what's happening here. Whoops. And then finally, I have some tests some assertions that make sure that if a password has 3 categories of character with different permutations of what those categories are, that those passwords are marked good. Here we've got, particular 3, a different 3, a different 3. And we run it and we get our dots, which is great. So this is what testing usually looks like. This is, sometimes referred to as example-based testing, which is, I say sometimes, I mean, referred to by the author of Hypothesis as, I hadn't heard that term before this library, but it's a good term because these are examples that I had to sit down and think of. I mean, thinking of mostly happened off screen, but you saw me do the Z$6 in front of you. And it's just, I guess there's several things I want to say. One is that these tests are great because they give me confidence that when given these inputs, my program behaves in the way I expect. And it's great. It's way better than having no tests. Also, I'm sure there's a bunch of people in the room who have strong feelings about tests. And yes, there's a whole bunch of reasons that tests are great. There's a strong argument to be made, and which is made by a lot of folks, that writing tests early or even first can sort of shape your program in really nice ways. My favorite thing about tests is that they let me confidently make changes to my program, because once I've got tests, I can, if my tests pass and then I make a change and then my tests still pass, I can be pretty confident that I didn't horribly break my program. Not super confident, but non-zero. And so that's great. So those are some good things about tests. Those are some things that example-based testing buys us. But there are a few cons. One is that, again, I had to come up with all these examples by hand, and it just wasn't fun. Like sitting down, I mean, the Carl's Jr. heard where that was funny, but the like test 2 categories thing, that wasn't any fun, et cetera. So that's one thing, is just like sort of a laborious, tedious process. At least I find it that way. I know some people really enjoy testing. And another thing is that right now we've got confidence that our program behaves well in the presence of these 12-ish inputs, but we have no idea what it does on a password that you don't see on my screen right now. What if I rearrange this, like I put an exclamation point over here instead, not even going to run it. You're just going to have to wonder, like, does my program work or not? So those are a couple cons. Thinking up stuff is just sort of a hassle, and example-based tests only buy you the confidence of particular examples that you thought to think of. And so that's where Hypothesis comes in. Hypothesis is a really useful Python library that generates example data for you to use in your tests. The way you install it is to go to, you type pip install Hypothesis, and Not going to do it because I already have, but this is how you install Python libraries. Once you've done that, you can use the thing. And so I'm going to do some sort of interactive stuff before I start writing code that uses hypothesis, because I think the simplest way, or rather, for me, the best way of getting my mind around hypothesis is to start with strategies. And strategies are the term that the author gives for these objects that he's created that generate data for you. So I'm going to show you what a text strategy looks like. And again, if the font size is just completely horrible as I type, then please let me know. Import strategies as ST. So this is how you import the strategies module. Rename it if you like. And then on the strategies module, there's just a jillion things. You can generate all sorts of things. They're all extremely well documented, these different things. So I learned about how to do this from going to the Hypothesis website and reading through it. And it's very simple, clear prose. Anyway, so that's good. And so that's how I happen to know that there is an st.text, and that it takes as input an alphabet argument, which is basically a sequence of the valid letters that you're going to allow this strategy to use. And some of the terminology here is going to maybe seem like weird or intimidating to beginners, like what's a strategy, what's sequence stuff. But it's, you're going to see this in action in mere moments, and you will see that what's happening is pretty straightforward. So I'm going to give this thing a string with letters like J, K. Well, that's good enough. I'm going to call this. That's what Control A does. Didn't Control A went to the beginning of the line. All right, we're gonna do this really quick from hypothesis. Import strategies as ST. I rehearsed this 3 times, and that didn't happen in any of them. Letter strategy is what I was trying to do, is equal to st.text alphabet equals ABC, F, G, H, I, J, K. Fine. So I've got this I've got this letter strategy thing, and again, bumping up the size in this window is weird. You can only parts of it up at a time. So I've got this letter strategy thing. What the heck is that? How do we use it? Here's how we use it. Here's how you can sort of use it when you're playing around with it before you plug it into your tests. Later on, I'll show you how you plug it into your tests. So when you create a strategy object, you can call .example on it, and that will generate some example data based on sort of how the strategy works and how you've configured it. Here we've got a text strategy, and we've configured it to use these possible letters. Let's see what happens. We got the string FJ. Cool. So let's do it again. We got that complete nonsense. Notice that C's, J's, etc. letters can show up multiple times. Sometimes we'll get the empty string. And just to give you an idea of what this looks like, we can do a for loop, print letter strategy dot example, and you can see that this thing generates strings for us, which is super cool. Generates strings with the letters that we told it could. Sometimes they are long, sometimes they're short, sometimes they're the empty string. And they tend to be different. They're not always different. Here we got a couple H's. That's okay. No big deal. We're generating a lot of these in these tests. So it's okay if there's a little bit of duplication. And there's one other thing I want to show you before I take a quick pause for questions, which is that, and we're going to be using this in a moment, the st.text strategy takes a few other optional arguments. A couple of them are min size, which basically does what you would expect. I'm not sure why I did that. The joys of demo life. And then we'll do max size equal to 60. So what I've tried to specify here is, there we go, an st.text with the same alphabet. And, basically I'm telling it, generate strings that are at least 5 characters long and at most 60 characters long. And then we can do that, and we can redo our for loop, and we can see that, yes, it does what we expected. So I hope at this point I've demonstrated to you that, Hypothesis has strategy things. They're neato. They're great for generating stuff. So that is what strategies are. That's how to use them. And as I plead the space for a quick moment, let me check my notes. I think it was basically going to say, now let's figure out how to use them in tests. So yes, here we have the section that I did this. And now let's talk about the given decorator. So, and I'll add some lines down here. Is that sort of helping what you want? So I can type in like in the middle of the screen? Higher, okay, oh geez. Good? Okay, all right. So let's use hypothesis in our tests. We're going to start by importing hypothesis in the same way that I did in the Python session. Import strategies as st. And then down here, we can say, well, I guess first we should figure out what we want to test. So I think that a good thing to test would be, again, to make sure that short passwords are marked as bad. I think that'd be a great way to use hypothesis. So let's figure out how to make a strategy that we can use in a test like that. So we want to generate short passwords, and a short password is a string with certain characters that we covered before, the lowercase, uppercase, digits, and punctuation. And the string could be at most 8 characters long, 7, because we want only short, bad passwords. So let's go ahead and write a strategy that does that. I'm going to go ahead and use the string module that comes with Python because it just has some nice sort of shorthands for the lowercase, uppercase, and digits, punctuation, strings. So these look like what you would expect. They're going to be the letters A through Z here and then uppercase, et cetera, et cetera. And by plussing them all together, I just make one big string that has all those things. The reason this is red is that I need to go up here. I need to import string, and then I want to rearrange this because it makes me happy. Great. So now that we've got this valid password characters string, let's make a strategy. So we can say to short password strategy, or let's just call it, I don't know, short password strategy is equal to an st.text with the alphabet of valid password characters and a max size of 7. Great. So we're halfway there, and so far we're using stuff that we're all sort of familiar with from the past 10 minutes. I'm going to introduce a new thing, which is the given decorator. Although first I'm going to write a test function. I'll say def test short, to short rejected via hypothesis, so I know sort of which test is which. Leave it empty for now. Then I'm going to import the given decorator. So decorators are a bit of Python syntax I'm not going to go into detail on. You can look them up if you are not familiar with them. But the main thing to know is that they let you modify how a function behaves, and they're just sort of a nice syntax for something you could achieve in another way. They look like this. You can you type the @ sign and then some stuff, and it's on top of a function, and maybe there's parens, maybe there aren't. It sort of varies. This one takes parens, and in particular, it then lets you specify the name of a variable that you would like to have access to in your test. So I would like a short password variable, and the value that the given decorator expects for these variables, or keyword arguments, whatever, is strategy. Unfortunately, we've already created one of those. So that is what it looks like to wire up, because of the number of new lines, I think. There we go. That's how you wire up hypothesis to a test, although there is one other thing, which is that we need to add a parameter to our test function that can sort of receive this value. And I'll show you what this looks like, so you don't just have to take my word for it. So let's just go ahead and do that right now. I'll add a print, and I will say short password. And so whenever our test is run, it will print its input short password. And what you're going to see when I run this in like seconds from now is that the given decorator, its presence causes hypothesis somehow working in concert to run our test a bunch of times, where a bunch is like somewhere between 50 and 200. I'm not super sure exactly what governs that, but it is configurable, as we will see later. And each time the test is run, it will get a different value as this sort of input here, and the values are as you would expect based on this strategy that we've created. So let's go ahead and run test. Good, I'm in regular mode. And so our test isn't asserting anything, so we'll get a dot that we didn't earn. But along the way, it is printing out a bunch of stuff. And this is basically what you might expect from a lot of ampersands. This is what you might expect given the sort of previous examples about strategies. So just demonstrating that, like, yes, this does what you would expect. Here, I've proved it. So now the remaining thing for our test is to write an assertion. We need to assert that is password good, the function that we were testing like 15 minutes ago. When it is given short passwords, it should return false. So let's run it. Let's see what happens. Okay, we got a failure. So let's figure out how to read this thing. So we can see the inputs that we gave to is password good. If these things are what you expect, password is the empty string. That's interesting. And we notice that it crashes on the first non-docstring line of the function. Something about string index out of range, but when paired with the fact that password is the empty string, it should make us suspicious that maybe we're doing something weird. We're not correctly handling empty passwords. So let's take a quick look at the code. And hey, my editor's telling me that this line is completely useless anyway because I never used this variable again. So I'm just going to go ahead and delete that. So we found a test via an example I didn't think to think of. And in fact, I'm not super cheating here. Like I didn't think to test the empty string when I was writing these example-based tests for the kids' programs. So now that I fixed it, hopefully we shall see a bunch of dots. Great, awesome. So this is really the meat of the thing. I'm going to show you another example. I'm going to go into more detail about. It's going to be a little bit more involved. But so far, we've seen how to use hypothesis, what strategies are, and how to connect them into your tests. Make tests that take a bunch of different inputs and are different each time, and you didn't have to think of the inputs, and the inputs are completely insane with the, well, they disappear off the screen, but all these ampersands, etc. There's a question? Yes.
So I'm wondering what kind of thing string.ascii lowercase and all those other items that are in valid password characters are.
Yeah.
Like what class of thing are there? And then sort of my secondary question, is that something that's relevant outside hypothesis, or was it made for hypothesis?
Right. So the string module is something that just comes with Python by default. And it's got some handy constants on it. So you'll notice the ASCII uppercase is, and I'll put this up here so hopefully it shows up for everyone. It's just a string. It's a string with the uppercase letters A through Z, and string.ascii lowercase is what you would expect there. It is just a constant whose value is the string A through Z. So it's not made for hypothesis. It comes with the library. I just happened to use it here because it was a lot easier than writing out the letters A through Z by hand. And there's actually sort of a coda to this that you'll see later in the talk. But does that make sense to the string module that has these useful constants? Sure. So, I mean, this is it right here. This is where I use it, and then I can scroll it. Sure. I use it here. And you'll notice, I'll just show you what it looks like to plus a couple of these together, which basically does string concatenation. I've somehow lost my autocomplete. ASCII lowercase plus string.ascii uppercase. And you will see that, it's just a string. You add two strings together, you get a longer string. This valid password characters thing is just a long string with all of the lowercase letters, uppercase letters, digits, and punctuation all in one string. And if we were in Clojure, I would be able to show you the current value of valid password characters. But I don't know how to do that in PyCharm. So, Exactly. Yes. Yeah. And for the video, the question was basically, is the alphabet argument just a string of the things that are the allowable characters? And yes, that is absolutely a great way of putting it. Any other questions? Yes, please. Close to you.
Yeah, I was wondering how many different permutations are run when you have that test function. Is it generating one single random value and running the test, or is it doing multiple?
Right. So it's a great question. Get back to where we were here. And I'm going to turn on verbose mode, which is something I meant to show earlier. There's a way in Hypothesis to, there's several ways to tell it to like be, more verbose, more loud about what it's doing when it runs your tests. And so I'm turning on verbose mode here. The way that you actually do this, what's happening under the hood, my editor is doing it, setting a particular environment variable. If you're interested in doing that yourself, you can just Google hypothesis verbose environment variable, and it'll be the top result. So I've turned on verbose mode. Now we can see the test in action. So it is doing, again, what you would expect. It's running it a bunch of times, and for a bunch, again, seems to be on the order of, 75. And that just seems to be the default. I don't know why it picks that number. Maybe it varies from time to time. I think it might have something to do with being time-based. There's bits I've seen in the documentation about how it wants to make sure that each test is no longer than a certain number of seconds. But I don't know if it's, if it runs it until that time or if it just always runs it 75 times. I'm not sure which. But as you can see, it runs it a bunch of times, and each time it gives it a different input. And so that's the main magic of Hypothesis. That's the main thing it accomplishes, and that's the main reason you want to use it, because, I pressed a button just now, and all these things happened. That's way better than me, sitting, like, okay, what if I had V8YQ, and then writing that in by hand. That's a real pain. So did that answer the question? Great. Anyone else? Yes, please.
Is it not smart enough to not test empty string multiple times, or?
Yeah, good question. I don't know the best way of answering that. The way that it actually generates stuff is like, I don't understand it. The guy, I think, is a PhD in it shows. Not in the sense that, like his code is good as far as I can tell. His documentation is stellar. And he's written a lot of great stuff on the website, which I will provide a link to at the end of the talk. But I do not have a fully developed understanding of exactly how Hypothesis generates stuff, and whether or not it's possible to get it to stop, doing the empty string several times. But as far as I'm concerned, like, it doesn't bother me enough to. I mean, it does show up a bunch of times, but I don't know. It hasn't bothered me enough to look into how to fix it yet, and I would be surprised if there was no way to fix that if it really bugged you. Sorry if that's not the most satisfying question. Excuse me, answer. Anyone else? Ace, please.
Hi.
Hi.
Either with Hypothesis or another library, is there a way for testing against pre-populated data sets that are huge, but you want to create semi-random data, but you care a great deal about cardinality and other aspects for testing? Either with Hypothesis or another tool, can you think of something that's good for doing that?
That's a great question. I don't know, if Hypothesis does what you want, because I'm a pretty novice user of Hypothesis. I've used it for the password thing and to test a tic-tac-toe program. That's about it. I haven't used it, in production at eWin. We don't have tests yet. They hadn't heard of version control before I got there, so I've got some work to do. But maybe someone else in the audience, maybe either now or after, can answer that question for you. But I'm sorry that I can't. Great. I think I'll pick it up again. So far we have seen, how to make strategies. We've seen the text strategy. We've seen that, yes, it takes as input a string of the allowable characters and optionally a min and max size. We've seen how to use the given decorator to plug a strategy into a vanilla high test, just a regular function. I mean, these 3 lines are the bulk of it. This stuff up here is just me making a string and a strategy. And we've seen that just by doing these things, we get tests that get run a whole bunch of times and that generate different things that we want each time. So, great. So I think we should write another test, and this will be the last one of the talk, but it's going to take a little while. Not too long, but the first version is not going to work. So let's try this one here. I'm just going to paste this in, and then we can take a look at it. So this looks pretty similar to what we had before. It's thinking about new lines. I'll just make that wiggly line go away. Here we are making another strategy. It's a text strategy. It takes as input the same characters, and this time we are saying that the min size of the strategy should be 8. So that's me saying to Hypothesis, hey, I want strings that again are valid password characters, opposed to valid password characters, excuse me, and they're at least 8 characters long, and I want to assert that those strings are marked as good. That seems reasonable place to start with a test like this. So let's run it, and we see some bad output. In particular, I want to turn off verbose mode. I'm going to be switching between verbose and regular a few times over the course of this talk. Never going to remember to do it in the right order, but oh well. So we see the Hypothesis has found a bug, or maybe it's found a bug. It's sort of unclear. So let's take a look. Again, the line that's falling over is this asserting that is password good is true. When given this particular password, it's turning into false, left-hand side. And the reason it's turning into false is that is password good returns false when given this input. So again, this is sort of human time. I look at this and I'm like, this is a bug, or is there something wrong in my test, or like what's going on? And well, it looks to me like our program being is password good, it looks like it's behaving well, because 8 A's are, yes, long enough to be a valid password, but that's one category of character, and for the Portland Public School District guidelines, we need to have at least 3 categories. So dang, it looks like we're going to have to do something more clever in order to get a Hypothesis to generate the things that we want. In fact, we almost sort of have to re-implement the stuff that the students are doing, which is kind of interesting. I don't really have anything intelligent to say about that. But in particular, I want to both communicate that like this, took a little bit of thinking when I got to this part. But again, I really want to just give massive shout outs to the author of Hypothesis, because I was able to piece this stuff I'm copying and pasting together. I was able to piece this together very easily using just the documentation of the library. I'm going to not show it to you. I'll link it after the talk in a gist. But mainly, I'm using this st.composite decorator in order to basically compose several strategies together. I make a strategy for lowercase, another one for uppercase, et cetera, and I make sure there's always at least 3 of them, and then make sure that the final product is at least 8 characters, and then finally add another filter that makes sure that the my username and student ID are not in the final password. And this time I'm going to remember that, excuse me, need to import random in order to make this code that I am hiding from you here work. So I've done all this stuff off screen, sorry, but again, I'll link it after this. Now that we've got it, we've got this passwords without student info strategy, and I can just go ahead and plug it into my test, and it will do what we want. First, let's run it in non-verbose mode. Let's see what happens. Got another failure. And at this point, everyone in this room is super good at reading this, so we can see that, yes, this password good is falling over on a particular password, and that password is these A's and exclamation points and zeros. And so what I am seeing, I look at this, is a password that is 8 characters long. Kind of hard to tell with the exclamation points, but I'm pretty sure that's true. And it's got so uppercase A, lowercase a, exclamation points, and 0. That is 4 categories of character. So earlier in our tests, we convince ourselves that our program behaves well in the presence of 3 categories of character. But what we're seeing now is that we've got the string and it's got 4 categories. Maybe there's something going on there. So let's take a look. We'll bring up the code, and wouldn't you know it? Oh, geez. Wouldn't you know it? My conditional here, which maybe I can bump up in the top of the screen. Conditional here is got an equal to 3, and it should be, of course, greater than or equal to 3 because it's fine to have 4 categories of character. In fact, that's probably good. At least it's both 3 and 4 are allowable values for this particular thing. So we've found another bug. We can make that change. Go back to our code, which is here. Then we can rerun the test. And we've got another passing test, another happy dot. I'm going to go into verbose mode because I think it's cool to see, earlier we saw what the short password test looked like, and that was cool. But seeing the insane stuff the hypothesis generates for long passwords, I would not think to write this down. It's complete nonsense. And I mean, this is really hopefully at this point you're like, oh, okay, this hypothesis thing, this, there might be something to this. I don't want to write this stuff. I want something that does it for me. So that's, and also just less important, but you can see that in the verbose output, it tells us sort of which test is running, and so we can see that it did all the short stuff, and now we're in the long stuff, and this is what it did for the long stuff. So we've got a test that verifies the long passwords are good, and that's great. But per the question earlier about the number of times to run tests, right now it's running the default number of times. I happen to know that there is one last bug remaining in our program that is very rare. And so we are going to trigger that. I'm going to show you how. And this might at first be like, oh God, what's the good of this tool if I have to bump up the number of times that we run our tests, but we'll talk about that more in a second. So I'm going to use the settings decorator from hypothesis import, settings. I'm going to add that to our test here. I can say that settings, max, I believe it was max examples. Examples is equal to 2,000. And this is a way in which, not 20,000, here all day. This is a way in which you can tell hypothesis, gee, you should run this test. I don't know why it's called max examples. Maybe it should be min. What do I know? But it's going to run it 2,000 times, basically. So we added that. Let's go ahead and rerun it. And not want to be in verbose mode because that would be, here we are. Okay. Going to run our test 2,000 times this time. The other ones are unaffected. Just this one that we decorated will run longer. It's going to take this many seconds. And this time it found something. So there's several things I'm going to point out. One is, okay, it found something. This is what it looks like. Fine. But the one more important thing is there's this should make some of you concerned. That, geez, if I have these tests and sometimes they pass and sometimes they fail, and it seems to vary based on the amount of times I run the test. Basically, you don't want to have tests that sometimes pass and then sometimes fail and then sometimes go back to passing. That is bad. That's called a flaky test, and flaky tests, as anyone who's sort of dealt with that problem can test, are just, they don't feel good. They eradicate your sort of confidence in your tests because you don't know if a pass is a pass or a fail is a fail. If you don't know if a pass is a pass or a fail is a fail, then what's the point of having tests? How do you sleep at night? So that is a very good question. Gee, does hypothesis have that problem? I'm going to demonstrate that it does not. I'm going to remove the settings thing. It's going to go back to running it the default number of times, and we are going to see that the failure persists. And here we have the same failing input that it's found. So what's happening here is that Hypothesis has a feature that the author calls the example database. And what it means is that once Hypothesis has found a failing input, it will remember it. So even if you have bugs that are really rare, and even if you don't think to bump up the number of times each test is run, because why would you want that? Both like it's another thing to think about and it makes your test suite longer. You can still sort of rely on the fact that if you run your test suite a bunch of times, it will eventually, might take a couple of runs, might take, maybe you won't find it for weeks, but it will likely, if you've written your strategies correctly and your assertions, Hypothesis will find your bug and it will remember it. It won't lose it. You know, it's not like, oh, geez, I had this bug and I can only see the input value, the failing input like 1 out of 3,000 runs of the whole test suite, and I forgot to copy paste it last time, so I have to wait another couple weeks. Don't have to worry about that. Hypothesis remembers things. The way in which it remembers things is it makes a .hypothesis folder, which I'm not going to actually list it, but just trust me that there is .hypothesis. I want to show you that it will autocomplete to prove to you that Hypothesis automatically creates this directory at the sort of root of my project over the course of runs, and that's where it keeps its stuff. It's got some like crazy stuff going on in there. I don't actually know how to interpret the contents of that directory. They seem to be some sort of binary format, at least some of the files. But that's where it keeps the quote unquote example database. And so the way you can wipe it is by moving that directory. So I can do that, and then I assert that if I rerun my tests with a default number of runs, they pass, even though we saw seconds ago that there's a bug in there on some input. So that was one thing I wanted to show you. I wanted to show you the example database. Does that make sense to people? It remembers failing inputs. Cool. I think that's great. The second thing is like the example database is good. I'm really glad it's in there. The second thing is so cool. It's called shrinking. And one thing I wanted to point out earlier is that Hypothesis is not the only library that lets you do this category thing that we're doing here, this generative testing, this property-based testing. In fact, I don't know my history super well, so I'm not sure if it was the first. The first tool like this I ever heard of is called Quick Check, and it's a tool for Haskell, and it basically does this. And so I'm not here claiming that Hypothesis invented the field or that it invented these features of example database and shrinking, which we'll learn about shrinking in a second. Also, Clojure, one language I like, has a library called Clojure Check, I believe, that does these things. And there's, if you're a deer and you enjoy Python and you also enjoy other languages, it's very possible that your language has a tool like Hypothesis. So all this is to say, there's other stuff like Hypothesis. Check it out. You can Google around. There's also a good talk on, good page on the Hypothesis website that has a breakdown of all the different ones per language. And now, finally, to the thing I meant to talk about, shrinking. So let's take a look at shrinking. In order to see it in action, I'm going to re-add my settings decorator, which see here, I've bumped the number of examples back up to 2000s. It's going to run it way more than the default number of times. To put us back in verbose mode, excuse the tiny font up there, doesn't matter. And I'm going to rerun the tests. So we're going to see a bunch of gibberish for a while. And in a second, we're going to interpret the output. So again, we see, okay, great, our test failed. Was a lot wordier about this time. We see the same failing input, or at least something that looks pretty similar. It's got these exclamation points and an A and an X. What's that about? Now let's scroll up and let's see what it generated. And its behavior is really interesting. You'll notice that, okay, so we can go all the way up and we see that sort of the short test is continuing to happily run, just unaffected by the stuff we've been doing down here. Then it gets to the long test and tries a bunch of stuff. It's all looking good. And then eventually it crashes, or not crashes, excuse me, it triggers a failure on this input, this JXG, QO thing, whatever. And then it keeps going. It keeps trying a bunch of stuff, tries this stuff. I don't know what that's about. And we get another failure here. Last time it was like JXG, now it's QXK, weird. So if we keep going, we'll see all sorts of different things. I want to go a little bit up to the sort of midway point. You'll notice again, XQK, but like there's these A's that are showing up. What's that about? Now we got 3 A's, 4 A's, cool. This is actually, it didn't behave this well when I was rehearsing this, and so I'm glad this is happening on the screen. What I'm trying to demonstrate is that the thing that the input that Hypothesis generated that caused it to notice the bug in the first place was relatively long and complicated. It was this, it was in the category of this crazy stuff, and in fact, it was like one of these. But then Hypothesis does this shrinking thing. What shrinking is an automated thing Hypothesis does for you that makes example failing inputs simpler. And I don't know how he does it. Like, I don't know how one defines the concepts of simple in this context. I don't know how one implements that at all. But it's there and it works. So again, the thing used to be crazy. It's gaining these A's. What's that about? It's gaining an exclamation point. And if we go all the way down, we will see that the final thing that it chooses to present us with, and the thing we will see if I switch back to regular mode and just see the regular output, I don't see the original completely insane input that caused it to find the bug. I just see the shrunk input, and this is like kind of interesting. And obviously the shrinking feature is interesting, but I want to talk about the input it's chosen to give us. This is something that just really impresses me. Like this hypothesis is really just seriously good software. Because the thing that we're seeing here, and I don't know how to make this go up higher, sorry, is we're seeing a string and it's got, well, you don't have to count them, but trust me, there's 8 characters, which is the minimum number that is required for a good password. And there are 3 categories of character, which I don't know how it figured that out, that concept. I never told it that. I just told it, here's how to sort of make strings. So it's giving us something that should be marked good, and it isn't. And it's pretty simple. And I happen to notice because I've run, these tests a bunch of times on student inputs, student programs rather, that when I see a shrunk example for a password in this particular program, in this particular context, it will usually be uppercase A's, lowercase A's, exclamation points, and ones. And if anything else is in the string that is not one of those things I just said, that it should make me suspicious. So here we see an X, which is not one of those things I just said. We see a lowercase x. What is that about? Let's take a look at our program. Go back to the code, and we can go, this lowercase letters and uppercase letters, and the lowercase letters lines up here, but it's kind of short, and oh, wouldn't you know it, WEXYZ, it was, it didn't have an X there, so I got to add my X. And if we re-add the X and we set this to the insane number of examples, it'll run for another 5 seconds. And hopefully this time our tests will pass. And so it's going to seem like, oh, geez, JR, you added that, just to see, again, it feels like I'm cheating because I planted this sort of rare bug. But this is something that one of the students did. They wrote out the thing by hand. They forgot the lowercase x. I never would have found this, never in all my days. Hypothesis found this for me. My jaw dropped. I was sitting there in the classroom and just being like, Omar, screwed up. So anyway, this is, again, hopefully something that makes the case that hypothesis is really good. It is really good at generating input data for your tests. It's really good at finding your bugs, showing them to you, remembering them, and shrinking them to a way that makes them relatively easy to interpret. And it's I don't know, like at a more sort of fuzzy level, it's just a delight to use. I've the time I've spent using hypothesis, I have never once been like, oh darn. I've always like, oh, that's pretty cool. And then I read the documentation and it's like, oh, that's well explained. And that's a rare experience with software, right? Like how often does that happen? So that is the bulk of my talk. I think that is everything I want to say, aside from the main takeaway, obviously, as I've probably said indirectly about 20 times over the course of this talk, is that you should try hypothesis. It's free, it's great, it's easy to use. I don't have any stake in this. I just tried it and I liked it and I want to tell more people about it. You can go to hypothesis.works to see its website and read the documentation. The author, again, in addition to just really good API documentation, also has a bunch of blog posts where he goes into details about how stuff is generated and might have some of the answers to questions that I wasn't able to answer earlier. And it's great. Also, don't forget to visit my website. And if you want to sign up for TEALS, you can do it now. So that is what I have to say. Does anyone have any questions? Yes, please.
Hi. I've not actually used Hypothesis before, but I have read on the website that it has different types of testing based on state. And I just wondered if you'd used that or had any experiments of it.
Yeah, that's a great question. I haven't used that. I've mainly, the sort of context here is that, I've been helping out with this Python class and I have, the teacher, Tamara, is in charge of it, but I've been sort of had a big hand in the direction that it's taken. So the kids actually don't know about object orientation in their classes. I've just been teaching them about functional programming, indirectly, which whatever. Maybe they'll be mad at me years down the line, but I think that I've taught them good stuff. And so anyway, all this is to say that I haven't, found occasion to use that feature, but for folks who haven't read about that, I read the same article and it's really interesting. The author of Hypothesis, in addition to having these generators that let you generate, normal sort of vanilla data like strings and dictionaries and et cetera, that can be arbitrarily complex and nested. For instance, the strings we were generating with this long password thing are actually, relatively complex and took a little bit of code to make. In addition to all those things, there's also a feature that Hypothesis has that lets you instantiate classes and have them, bang on each other in various ways in different permutations. I don't know if you have like I haven't done it in a long time, so I can't think of any examples, but people who program in in an object-oriented context are familiar with the idea that you have classes, you make instances of them, they interact in different ways, and sometimes, depending on the order in which they interact, you might find subtle bugs. Hypothesis has a feature where it automatically generates these permutations for you, so it can even handle testing in that way. So anyway, basically, the answer to your question is that no, I've just read the same article, but I don't know any more than you do. But thank you for bringing it up because it's a really compelling feature, one of the many that Hypothesis offers. I should be in sales. Anyway. Anyone else? Okay, I think that's it. Well, thanks so much for coming. I appreciate everyone coming out on like the one nice, day remaining in spring. And cheers.